Hello, this is Dr. Glasbrenner from George Mason University, and in this video, we will learn about the general components of a data visualization. Data visualizations follow enough of a pattern that we can devise a taxonomy for them. The elements of any given data visualization can be broken down into four basic elements: visual cues, coordinate systems, scale, and context. Visual cues form the building blocks of any given visualization. In general, they can be categorized into one of 9 separate visual cues. In any given plot, only a subset of these cues may be present. It is not required that all 9 show up in one plot. The 9 cues and their data types are as follows. The position visual cue is represented with numerical data. This is where data is physically located on the plot, and it shows us how data sits in relation to other things. The length visual cue is represented with numerical data, and shows how big something is along one dimension. The angle visual cue represents numerical data, and shows how wide something is and whether or not it is parallel to something else. The direction visual cue represents numerical data, and can indicate slope in a dataset or, in a time series dataset, whether the trend is going up or down. The shape visual cue represents categorical data, and shows what group different data points belong to. The area visual cue represents numerical data and shows how big something is along 2 dimensions. The volume visual cue represents numerical data and shows how big something is in 3 dimensions. The shade visual cue can represent either numerical or categorical data and can show the extent to which a certain feature is present or how severe it is. Last is the color visual cue, which can also represent either numerical or categorical data and also can show to what extent or how severely a certain feature is present. Keep in mind that, when you are using color, that you should be mindful of red-green color blindness. The second basic element of a data visualization are coordinate systems, of which there are 3 types. There is the familiar Cartesian coordinate system, where we describe points using x and y coordinates measured relative to 2 perpendicular axes. There is the polar coordinate system, which is the radial analog of the Cartesian coordinate system. In this coordinate system, data points are identified by a radius rho and an angle theta. The third type of coordinate system is the geographic coordinate system, which corresponds to locations on the curved surface of the Earth, but need to be represented in a flat 2-dimensional plane. The third basic element of a data visualization is scale, of which there are 3 types and will seem familiar based on our earlier discussions. The first is the numeric scale. There are several kinds of numeric scales, with the most common ones being the linear scale, which is the default scale you will see the most often, the logarithmic scale, which counts along an axis in powers of a base number such as 10, and the percentage scale, where you consider the relative fraction of observations instead of their absolute total. The second kind of scale is the categorical scale. In the categorical scale, the variables may have no particular ordering, or they may be ordinal, where the position in a series has meaning. Finally, there is the time scale, which is a numerical quantity with special properties. Because of the calendar, it can be specified using a series of units, year, month, and day. It can also be considered cyclically. For example, years reset back to January, or a spring oscillating around a central position. The fourth basic element of a data visualization is context. This refers to annotations and labels that draw attention to specific parts of a visualization. Examples of this include titles and subtitles on a plot, labels along the axes that depict scale and indicate the name of the variable, reference points or lines drawn on the plot, and other markups such as arrows, text boxes, and so on. It is possible to overdo the markups, so always try to keep it minimal and focus on the most important things you want to highlight. Let's now apply these ideas to this example plot showing the trend between the engine size and gas mileage on the highway for several different types of automobiles. For visual cues, we see position and color with the data points, showing us the gas mileage versus engine size trend across several classes of cars. The coordinate system shown here is Cartesian. The scale is linear along both the horizontal and vertical axes. For context, we have the plot title, the axes labels, and the legend on the right. As you're getting familiar with data visualizations, it's worth seeing if you can successfully break down and categorize the elements of other visualizations that you see.